is made up of a which material is a very primary question. We will start from learning this case. Yes, you are aware about that new paper pattern that is containing 50 MCQ and 50 descriptive part, and in a 50 descriptive part, you may get this question whether it is cases for the 4 marks. You are aware that 4 questions will be asked of a 4 marks. And this question or another question from chapter number 7 that is called as alternating current. Next one is called as chapter number 14. There will be another question. And fourth question of a 4th mark is might be the radius or nuclear energy equation from chapter number 12. These are the 4 primary questions they are asking alternative years. So be prepared for that. From this chapter, there are 2 questions having that eligibility to be asked for the 4 marks, because if you have gone through some of the examples of this chapter, they are very much miniature in nature. They are very much smaller in nature, so they are not eligible for the 4 marks. But yes, prism and combination of lenses. Then after that, you are aware about that equation of 2 lenses. These are the questions to be asked for the 4 marks. Now, very fundamental question is that prism is made up of a which material? So prism is made up of a different type of material. Very first one and basic one is called as a glass. Then is called as a fused quartz. Third one is called as a calcite prism. It is made up of a material calcite. Fourth one is called as a plastic. Each material have their own refractive indexes. So as per your refractive index will be there whenever you are applying your ray on any surface of the prism. That surface will divert that path of that incident ray, and you will get that diverted result of incident ray. One more thing is that if it is made up of a glass, or if it is made up of a fused quartz, then or maybe plastic. If it is made up of a glass and fused quartz, you may get that 7 colors on the another side. Incident color is or incident ray is monochromatic. Monochromatic is called as a single source of light, or maybe white light or transparent light, simply. And on another side, you will get that 7 colors that is called as a Vibgyor. We will, after this theory, capable enough to describe that which color deviates more or less. And if you have used that prism made up of a plastic, then you may get some dispersion and another side, but it is not showing you full 7 colors. There are chances that you may get either 2 or 3 colors. That's it. Nothing more, nothing less. But yes, if normally we are using that prism made up of, let's say, glass and fused quartz. Now, there are different type of prisms are available. That is called as after calcite prism is also that. This calcite prism is combination of so many different type of prisms in a single prism. If you have seen that symbol of DLF, you are aware about that brand. That is called as a, dealing with the construction branch. So it is holding such type of logo. So same type of thing you can experience in the calcite prism, that you have so many small prism part placed in a single prism. So this is called as a calcite prism. Into the prism, there are small parts are also there. Each part is behaving as independent prism. So you may get that different type of result as well. Some people are using that in a single prism. They are putting such type of a small prisms inside in a single prism. It is made up of a different material, then result will be different. So we are not going in the depth of it. We will only follow that prism made up of either glass or maybe fused quartz. Chalo, initially starting with the very first part of this prism theory is that I am putting a simple theory of a prism or a figure of a prism. Initially, prism contains 4 sides. Bottom side is not considered. Now, I am placing a ray on its surface ABC. It is look like equilateral triangle. On its surface AB, I am putting my ray AB. If you understood this figure, then it is quite easy for you to place its equations as well. So on a surface of AB, I am putting my ray or applying the ray. And I want to understand that what amount of deviation it is experiencing. So I'm drawing a normal over there. So this is my normal. Normal will give you that what amount of refraction happen and what amount of deviation it is showing or indicating. As you are aware that whenever my ray is passing from its rarer to denser media, first of all, we have to now decide that which one is rarer and which one is denser. So my ray is starting its journey from the air. So you are aware that the refractive index of air is 1. It is called as a rarer media. And my glass or fused quartz is you can say thicker in a nature, so its refractive index is higher. It is called as a thicker media. So my ray is starting its journey from the rarer to thicker media or rarer to denser media. So my ray is somehow getting near to the normal. So now it is changing its path and it is coming closer to the normal line. So it is now coming closer to the normal line. Again, I am drawing a normal line perpendicular. So it will be giving me some idea about it. So I am drawing a normal line. So it will give me that idea what amount of refraction happened. Now you are aware that whenever my ray is getting away from the denser to again rarer media, it means that it is again coming out from the prism and again coming out in the first media as well. So whenever it is coming back to its rarer media from the denser, it is getting away from the normal. So my ray is getting away from the normal. So this is my away from the normal expression. Now, these are the paths shown as actual path. But you are aware that it is after refraction this path happened. But whenever we are following normal geometry, you are saying that it should pass in a straight fashion. If there is no refraction, then my ray should pass in a straight fashion. ऐसा straight line में move होना चाहिए था, but नहीं हुआ. Again, it should pass in a straight fashion, but ऐसा होता नहीं है because it is experiencing deviation in a such a manner. So I am extending this ray at the back side. So it is showing me indication that, let's say I'm naming it as a O, I'm naming it as a M, naming it as a C, or you can say D, and this is my ray E. DE is my emergence ray. Emergence means coming out ray. And if I am showing my OM ray extended in a straight fashion, and I am comparing my DE ray, which is actually coming out, so it is giving me one angle that is called as a deviation angle. So you can see that this dotted path is of my OM ray. So let's say I'm just indicating very properly. So DM ray is my actual path, and now I am showing that with such type of fashion. So it should pass in a straight fashion, but it is experiencing that refraction. That is why it is now deviated. So my M2 F path is projected path, and my DE path is actual path. So after actual and projected, there is an angle that is called as a delta. It is called as a deviation. So I am putting that delta is called as a deviation angle. Next is that I have drawn one normal. Let's say I'm giving this normal number N2 and this is normal number M1. The normal N2 line and the DE line, that is how my ray is coming out. So E is called as the angle with which my ray is coming out. That is called as the emergence angle. So quite careful to place this angle. So delta, it means that my ray should pass through MF, but it is experiencing such type of refraction because of the N2 and because of the N1, where it is coming or entering in the prism and coming out of the prism. I am viewing that my ray is DE. It means that delta is that deviation angle between the projected or I have thought path and DE is actual path. So these are the two things you have. Now I have to put some angles as well. So very first angle is that at angle side N1, my object is first of all entering, that is called as I. So I am putting that I is equals to incident angle. Next is that my array is entering into the media and it is somehow deviated. So with the normal N1, it is making that refraction angle R1. So let's say R1 is called as a refraction angle with the normal. So I am just putting that with normal N1. And let's say I have R2. This is the angle with my normal N2. So these are the two angles I have. Now you can see that it is looking like if I am putting the such type of nomenclature, I am adding one more name that is called as G and I am putting that H. So you can see that one parallelogram which is dealing with the M, G, D and H. And if I am comparing this angle A and angle H, so you can say that R1 plus R2 and angle H is called as a 180 degree because it is look like a triangle MDH. And you can see that another triangle that is called as a MAD, and A and H both are opposite sides. So both will fulfill the condition of our equilateral triangle. So angle A, which is called as a prism angle. Always remember your prism's angle are equivalent in this angle. So that is called as A is called as a prism angle, and that is always 60 degree. Because I have used this word equilateral triangle. So it is look like that triangle and each angle contains 60 degree. So always whenever you are solving example, prism angle is always 60 degree. So we will place this in examples, but for your memory, I am putting over here. So now figure is quite clear to you. That is called as A, M, and D. It is a triangle. So angle A and બાકીના angle નું just addition કરું તો that is called as a 180 degree. Yes. Another thing I will just say that તો opposite માં પણ એવું કહી શકીએ આપણે કે ભાઈ MH અને D ના જે angle છે it is called as a 180 degrees. So angle A, because I am just using this parallelogram, angle A, M, H and D equals to 180 degree. તો મને પેરેલેલોગ્રામ દેખાય છે AMHD, તો હું MH અને D જે છે એની જગ્યાએ પ્લેસ કરી દઉં છું 180 degrees. ચલો પ્લેસ કરતા જઈએ. Angle A, angle MHD equals to 180. So from the figure, angle A plus angle MHD equals 180 degree. And let's say I'm just putting that parallelogram AMHD. Next is called as a from figure. From figure, I can just say that MHD, angle M, angle H, and angle D equals 180. So let's say angle M, angle H, and angle D equals 180 degree. But I am aware from the figure that angle M is R1 and angle D equals R2. So let's say angle M is R1, angle H I am putting as it is, or you can say that MHD as well, कोई भी प्लेस कर सकते हो, plus angle D is equals to 180 degree, where angle H बोल सकते हैं या angle MHD. तो our equation will be angle R1, angle MHD and angle D equals 180 degree. Now comparing equation number 1 and equation number 2. So equation number 1 equals equation number 2. So we'll have an angle A plus,
सर R2 नहीं आएगा?
हाँ R2 आएगा ना बेटा, D भी लिखा हुआ तो R2 लिख लेंगे उसकी जगह। चलिए, तो ये हो गया हमारा, देन R2, D की जगह R2 प्लेस करना है। तो एंगल A प्लस एंगल MHD लेफ्ट हैंड साइड हो जाएगा, एंड वी हैव एंगल R1 प्लस एंगल MHD plus angle R2. MHD will be cancelled from the both the sides. So we will have angle A equals R1 plus R2. ये हमारे काम की चीज है. So इसको equation number 3 I am just placing. I just follow these steps from the figure and I have just derived that R1 plus R2 is combination of angle A. अब directly भी लिख सकते हैं कि एंगल A एंड एंगल H का दोनों का पोजीशन जो है वो सामने सामने सेम है, तो एंगल विल बी इक्वल. ओके, तो ये करने के बाद नाउ वी हैव रिसीव्ड दैट इक्वेशन नंबर थर्ड वन. नेक्स्ट स्टेप, अभी मुझे क्या करना है, तो व्हाट आई हैव टू डू इज दैट अगर R1 एंड R2 जो है तो ये एक्सप्रेशन है, तो हम लोग ऐसा भी तो बोल सकते हैं कि नाउ फ्रॉम द फिगर डेल्टा इज कॉल्ड एज अ डेविएशन एंगल, और बाकी जो एक्सप्रेशन है तो दैट इज कॉल्ड एज, ऐसा बोल सकते हैं डेल्टा अगर आगे का एंगल है तो सम ऑफ द इंटीरियर एंगल इक्वल्स टू एक्सटीरियर एंगल. सामने सामने वाले एंगल इक्वल होंगे तो ऐसा भी तो बोल सकते हैं कि R2 यहाँ पर रहेगा, R1 यहाँ पर रहेगा. तो ऐसा भी तो बोल सकते हैं कि भाई R1 और R2 की जगह we will say that I minus R1 is R2 and E की जगह E minus R2 is R1. तो फिगर से फिर से बोल रहा हूं मैं, सम ऑफ द इंटीरियर एंगल इक्वल्स टू एक्सटीरियर एंगल का फॉर्मूला हम लोगों को प्लेस करना है, तो हम लोगों ने जो दिखाया है वो हमारे काम में आएगा अभी. तो डेल्टा जो है इट इज अ नेट एंगल, इट इज कॉल्ड एज अ डेविएशन एंगल, जो दोनों का सम है. किस किस का, तो बोलेंगे हमारे पास I माइनस R1 दिख रहा है लेफ्ट हैंड साइड देखिए, और दूसरा एंगल दिख रहा है हमको E माइनस R2 जो भी हमारे पास है. तो हमको ये वाला एंगल R2, ये वाला एंगल R1 मिल सकता है, तो हम लोग यही चीज फॉर्मूला में लिख लेते हैं. तो लेट्स से नाउ आई हैव फ्रॉम द फिगर दिस फॉर्मूला. तो फ्रॉम फिगर I have a delta is called as my deviation angle equals to I minus R1 plus E minus R2. Here arranging these terms will give me delta equals to I minus R1 plus E minus R2. So I am just simplifying these terms, minus R1 plus R2. But from the previous expression number 3,
R
I can just say that
relation.
equation number 3 is suggesting me that R1 plus R2 is called as a prism angle. So I am putting that it is called as A. So I have I plus E minus A. So my equation is ready. I plus E is equals to A plus delta. This is the equation of a prism. तो 2 मार्क के लिए ऐसा पूछ समझना हो तो पूछ सकते हैं कि भाई फ्रॉम फॉर द प्रिज्म डिराइव दैट I plus E equals A plus delta. तो यहाँ तक का तो काम क्लियर हो गया. Hopefully that it is quite clear to each and everyone. Now नेक्स्ट सेगमेंट, मुझे उसके केसेस फाइंड करने हैं. तो चलिए केसेस के लिए आगे चलते हैं. I can say that if I equals to delta, or you can say that I equals to E is equals to minimum deviation. So delta M is called as a minimum deviation. अभी लेट्स से फिगर को देखते हैं. तो फ्रॉम द फिगर यू कैन सी दैट अगर मेरा डेल्टा यहां पर है तो मैं ऐसा बोलूं कि मेरा जो इंसिडेंट एंगल है इतना ही एंगल मेरा ई हो जाए, तो उसका मीनिंग ऐसा हुआ कि माई रे विल पास इन अ वेरी स्ट्रेट फैशन। यहां से एंटर हुआ, सीधा बाहर निकल गया, तो मेरा जो एंगल होगा दिस एंगल विल बी इक्विवेलेंट टू ई। तो डेविएशन जैसा कोई कॉन्सेप्ट ही नहीं मिलेगा, तो उसको बोलते हैं मिनिमम डेविएशन और नो डेविएशन। बट ऐसा तो पॉसिबल नहीं है बिकॉज इट इज अनदर मीडिया। तो मीडिया में दूसरे में एंटर हुआ विच इज होल्डिंग अनदर रिफ्रैक्टिव इंडेक्स। तो मिनिमम डेविएशन जो है या तो डेविएशन होना ही होना है। तो देयर इज नो सच केस वेयर यू कैन से दैट देयर इज नो डेविएशन। बट यस, हम लोग एज्यूम तो थियोरी में कुछ भी कर सकते हैं। तो इफ माई आई इक्वल्स टू ई, दैट डेविएशन इज कॉल्ड एज अ मिनिमम डेविएशन। तो अभी इक्वेशन में प्लेस करते हैं। हमारा इक्वेशन है आई प्लस ई इक्वल्स ए प्लस डेल्टा। तो आई और ई तो इक्वल है, तो डाल दीजिए ए प्लस डेल्टा। तो आई हैव टू आई इज इक्वल्स टू ए प्लस डेल्टा। तो आई इक्वल्स a plus delta m divided by 2. So I got another expression. So this is called as I equals a plus delta m by 2. अभी यार मुझे तो एक और भी चीज फाइंड करनी है। तो मुझे रिफ्रैक्टिव इंडेक्स फाइंड करना है। किसका? प्रिज्म का। ओके, कर लेते हैं। तो फर्स्ट ऑफ ऑल उसके लिए मैं दो पोर्शन डिवाइड कर लेता हूँ। अगर ऐसा कुछ कंडीशन है कि भाई मिनिमम डेविएशन हुआ, तो फर्स्ट ऑफ ऑल एक ग्राफ से वी विल जस्ट शो इट कि क्या होता है। जैसे कि भी मेरे पास एक ग्राफ यहाँ पर है एक्स एक्सिस पे, और दूसरा जो ग्राफ है यहाँ पर है वाई एक्सिस पे। नाउ एक्स और वाई पर दोनों पर आई एम जस्ट पुटिंग दैट ग्राफ ऑफ डेल्टा वर्सेस आई। So let's say this is my delta and this is my I. So on the y-axis, I am putting that delta, which is called as a deviation angle, and this is called as my I, which is called as an incident angle. One point where I and E both are equal. So let's say I am putting this point and I'm drawing this such type of numbers. So this is the point I am putting that which is fulfilling my condition where I equals E. So at that time, it is showing me minimum deviation. So I have to now represent its a slope. So be careful, such type of a slope you have to draw in your practicals as well. So these are the points where deviation occur, but I am highlighting this part which is only indicating that minimum deviation. So this point is called as a minimum deviation point. So now it is quite clear to you that when I and E both are equal, that minimum deviation occur. So this is the point where minimum deviation happen. नाउ आफ्टर मिनिमम डेविएशन अगर मुझे इसका फॉर्मूला दूसरा भी फाइंड करना है, रिफ्रैक्टिव इंडेक्स का फाइंड करना है, तो अभी रिफ्रैक्टिव इंडेक्स के लिए इफ आई एम जस्ट इंडिकेटिंग दैट कि भाई पहला कंडीशन है कि आई एंड ई बोथ आर इक्वल, देन इट इज कॉल्ड एज मिनिमम डेविएशन। तो सेम कोर्स आई विल अप्लाई ओवर हियर दैट at that time r1 and r2 both are equal। अगर आई एन ई डेल्टा मिनिमम है तो दूसरा कंडीशन ये भी तो होना चाहिए कि R1 एंड R2 दोनों सेम होने चाहिए, क्योंकि सी द फिगर। सर दोनों अगर स्ट्रेट लाइन में, अगर मेरा जो रे है वो स्ट्रेट लाइन में पास आउट हो रहा है, तो नॉर्मल से जो एंगल इसका होगा उतना ही एंगल इसका भी होगा, बिकॉज आई एंड ई आर इक्वल। यस, तो भाई वो भी प्लेस कर लेते हैं। अगर ऐसा हुआ, दिस इज एजम्पशन, तो इक्वेशन नंबर थर्ड कैसा हो जाएगा? तो इक्वेशन नंबर थर्ड वन will look like this one: r plus r equals a, so 2r equals to a, so r equals a by 2। Let's say I am giving this equation number fourth one, I am giving this equation number fifth one, and I am finding it out my equation of refractive index। चलिए भाई, स्नेल्स लॉ होता है तो ही रिफ्रैक्टिव इंडेक्स फाइंड कर सकते हैं, तो अप्लाइंग स्नेल्स लॉ, तो लेट्स से Snell's law, you are aware that it is applicable to the two or more than two media, but only refraction is there, then Snell's law is there. N1 sine theta 1 equals N2 sine theta 2. थीटा 1 की जगह डाल दीजिए इंसिडेंट एंगल, क्योंकि वही इंसिडेंट एंगल ही होता है, एंड थीटा 2 is called as a refraction angle because our media is thick, and theta 2 is called as our refraction angle. So, and you have another thing at the same time. N1 is air. So N1 is the first media, air. Its refractive index is 1. That is a worldwide known thing to you. And N2 पता नहीं है, जो हमको find करना है उसको N2 you can keep it as it is or you can place N. चलिए सबका वैल्यू प्लेस करना स्टार्ट करते हैं. तो we will have a sin I, N1 हो गया 1, N2 we have to find it out. Sin theta 2 is called as a sin R. I and R ka value you have available from fourth and fifth. So I am just using that fourth and fifth one. So I can have a sine I equals to A plus delta M divided by 2, and sine R is called as A by 2 and into N तो है ही है. भाई मुझे तो n फाइंड करना है. ओके, तो n को फोकस बना लीजिए. तो माय इक्वेशन इज sin a plus delta m divided by 2 whole to the base sin a by 2. So this is your work of 4 marks. If you are from the prism, derive the expression of refractive index. So equation of refractive index of a prism is ready. तो नॉर्मली हम लोग ऐसा बोलते हैं कि भाई प्रिज्म का रिफ्रैक्टिव इंडेक्स तो नॉर्मली कोई भी फाइंड कर सकता है, या प्लास्टिक ले लीजिए, ग्लास का डायरेक्टली प्लेस कर लीजिए, वो भी हो सकता है. और या तो आपको फाइंड करना है तो प्रिज्म का एंगल तो हमको पता है 60 डिग्री होगा, डेविएशन फाइंड कर लीजिए एंगल प्रैक्टिकल से, प्लेस कर लीजिए तो रिफ्रैक्टिव इंडेक्स पता चल जाएगा. तो दिस इज द इक्वेशन ऑफ रिफ्रैक्टिव इंडेक्स ऑफ अ प्रिज्म, sin a plus delta m by 2 whole to the base sin a by 2. So this is the expression containing total net 4 marks, and there are so many MCQs can be found out, you can find out in a NEET or JEE. Let's say n equals to sin a plus delta m by 2 and sin a by 2. This angle is a very much a smaller one. So by mathematical notation, if theta is very much small, so it is denoted as sin theta is nearest to equals to theta. So in the same expression, we can say that n equals a plus delta m divided by 2, a by 2. So 2 will be cancelled out. We'll have a plus
A,
delta m divided by a. So what I got is
A will be same.
na minus a equals delta m. So my expression is called as a minimum deviation n minus 1 into a. This is the formula which is dealing with the prism with a minimum deviation or no deviation or less deviation. If I'm using this word minimum, less, or no deviation, why? And with the expression, I can observe that which color may have a more deviation, which color may have a less deviation. So let's say I am drawing again a prism over here, and then observe that what happens with a minimum or less or no deviation with which color. Let's say I am putting these points A, B, and C. I am applying my ray which is incident on this surface. So let's say this is transparent light. So I am putting this ray. It is somehow passing in a straight fashion, and this is the result. And this ray I am drawing above here, it is called as my straight fashion ray. What I am getting over here is that this straight way, which is experiencing no deviation or less deviation or minimum deviation, is red color, and this is my violet color. So I can say that if I am seeing this deviation delta, so my incident ray and my red color are both in a straight fashion, while my violet is experiencing maximum deviation. In between you may get 7 colors with your. So you can say that red color is having no deviation or less deviation, while violet experiencing maximum deviation. So you can put one more MCQ over here is that whichever color having higher intensity, which is experiencing less deviation, the color which is having lower intensity is experiencing maximum deviation. So this is one more MCQ. So my expression which I have placed over here is that delta equals to n minus 1 into a or a into n minus 1. So I am putting this for the two colors, and which will give me delta for the red color, deviation for the red color equals to a into n minus 1, and delta for the v is equals to a into n minus 1. So it will give me that deviation equation for both. So I am just putting this formula. Delta equals to delta for the violet color is maximum. Delta for the red color. This is called as a delta deviation angle between red and violet. So yes, my equation will be same, a into n minus 1 minus a into n minus 1. So this is indicating me that deviation between the red and violet color. So this is the very first discussion with the deviation part. Apart with that, I am putting one more case in front of you, that is this thing. If I am putting a prism, if I am putting my ray, which is transparent or white in color, and another side I am getting that my 7 colors, from violet to red or red to violet, and as far I'm in a deviation manner, maximum to minimum deviation, so I can say that maximum deviation occur when violet color is there and minimum deviation occur when red color is there. This is the story of a single prism I have placed. If I am putting another prism over here, then what happened then? If I am putting another prism over here, then any surface of the prism has been placed like this one. Again 7 colors has been deviated and it is giving me the transparent light. If a third prism is placed, again transparent light is passing and I am getting that 7 colors. So you can just put a small conclusion over here that I am putting a Mentos over here, number of a prism, and then I am putting that it's a result. If my number of prisms are odd, I am getting that 7 colors with your. And if my number of prism are even, I am getting that same light back. If I have placed a transparent or white light, I will get a transparent or white light. I have placed monochromatic light, then I will get monochromatic light. So number of prism will decide that what amount of deviation or what amount of color you will get. First prism means odd numbers of prisms are there. I have placed 3 prisms in front of you, then I will get that 7 colors, and at the end of the last prism. And if I have placed that even number of prism, then I will get that same light back. Let's say you can see that on a second prism's end, whichever type of light, monochromatic or transparent or white light you have applied, you will get the 7 colors back. So this is the another MCQ can be asked, that if number of prisms are 8, then I have placed that transparent or white light. So you will get that same amount of light back. So these are the MCQs related with the prism as well.